All right, legends, this is Mr. Mays. I'm so excited to be visiting with you through the digital space, right? The metaverse. And today we're going to be looking at sampling distributions for the difference of two proportions, right? As you can see presented before you here. Okay. Now, the wonder of what we're doing today is I want you to take a quick look at this graph. Now, you'll remember this from class. But as always, anytime we're doing a confidence interval of any kind, right, we're working with sampling distributions like these, right? And so today we're going to learn how to take a sampling distribution for the difference of two proportions and turn that into the main topic of this lesson, which is confidence intervals for two proportions. Okay. So you'll note that I've already labeled the two proportions we're working with. They're P1 and P2. And you'll also notice that the distribution of samples is based on subtracting P2 from P1. So we take P hat 1 minus P hat 2, right? And the way, of course, the sampling distribution works, just to make sure we're all clear on this, is we take a single sample and another single sample's proportions, and we subtract them one from the other, right? So we find the difference. And then we presume that we had done that many times, right? And if I may really quickly, let me just dive in here. You'll take a look and you'll note that in calling this the sampling distribution of P hat 1 minus P hat 2, that would be the first part of our confidence interval, right? We would do P hat 1 minus P hat 2, right? And then you would take that concept, that value, right? And you would say plus or minus. And now we're going to create the margin of error. Now, this all replicates in everything we've talked about previously in confidence intervals. So I'm going to zoom past a lot of the things that you should be comfortable with, right? If you're not comfortable with confidence intervals, go back to your Unit 6 notes and make sure you're super sure on why we're making a sampling distribution, why we're subtracting one P hat from another P hat, why P hat is being stratified as an enormous distribution of different values that we hypothetically might see. Now, you'll remember also from one sample confidence intervals, in this case, because we're doing proportions, we will have a Z critical value. And just like it says in 6.1 notes, that critical value is determined by the middle percentage of results in our sampling distribution that we expect to use to determine our level of confidence, right? So our confidence level will denote that. If it's 95th confidence level, right, 95% confident, we're going to be using a Z critical value of 1.96, for example. Okay, so with all that in mind, the last part of this equation, as you might remember, is basically just the standard deviation for the sampling distribution, and that is right here. So Z times that, I'm going to just write it on the outside, Z times that would represent the margin of error. And that's all you have to be able to do to calculate a confidence interval for two proportions. Now, I could continue to just yarn on after looking at this distribution, but what I'm hoping is that you've already got like a vague idea of everything we're talking about here. And now I can go into detail by solving a problem. So what I'm going to do is I'm going to just scroll down to an example problem that you might see. Now, I recommend alongside these video notes, you scan through the slides and try a couple of the problems there just to warm yourselves up. But this is my chance to kind of go in more depth and make sure that you understand how we would calculate a sampling distribution. Well, not calculate the sampling distribution. You're going to have the sampling distribution, so to speak. How to calculate a confidence interval for two proportions. So let me write that at the top. It's so wonderful to have you here. Gosh, every time I do this, two proportions, I'm thrown into the wonders of how joyous it is to work with statistics. Okay, so let's look at our problem. It says young adults living at home. Okay, a number of young adults, ages 19 to 25, still live in their parents' homes. A random sample by the National Institutes of Health include number of men, number of women in this age group. Survey found X number of men and X2 number of women lived in their apartments, or with their parents, I should say. Construct and interpret a 99% confidence interval for the difference in the true proportions of men and women in that age group who live in their parents' homes. Take a moment, pause the video, read through the question, map out your variables. Alrighty, now you may remember this from class, but hopefully you want to pause there and you're ready to roll with me. Just like any confidence interval, we're going to do panic. Except we're doing two kinds of panic here. Right? So the first thing I'm going to do is set up my P1 and my P2, right? These are my two true proportions. actual population proportions. So P1 will be the true proportion, I'm going to abbreviate, of, we'll say, young men living at home. And then we'll, of course, have the true proportion of young women living at home. Okay, so we're all set on those two fronts. We've got our parameters set. Now, obviously, you don't have to put your parameters in because you can do them in your conclusion, which I recommend you do, but it's very important, in my opinion, to put the parameter in because then you don't miss it and you don't have to worry or feel anxious about any of your denotations. You're going to notice the way I like to do it, I set up my parameters at the beginning and then I reuse P1 and P2 throughout because I've already set up what they mean. So let's follow this procedure. My assumptions. Now you remember assumptions. These are the same assumptions we had for confidence intervals for one sample for proportion. The first one is independence. Now how do we know they're independent? We need the 10% rule. And what that's going to look like in this case is twofold. We need to say that 10 times 2253, which is the total number of men, is less than all young men. And we need to say that 10 times 2629 is less than all young women. And we can make those assumptions. So we're done. We've checked independence off the list. Now, next thing we need to do, of course, is check to see, is it approximately normal? Let me write approx. You know I love approx. Is it approximately normal? Let's panic through it together, shall we? Now, the way we check this is we normally do, right? I went ahead and found the proportion for men, right? So I went ahead up here and I took 986 and divided 2,253, I should say, by it. And that got 0.438, right? So you'll do P hat 1 times 2253, right? And then you'll do 1 minus P hat 1 times 2253. And the assessment here is that both of those should be greater than or equal to 10. You'll notice I put that comma between them. That is clearly stating that those two separate things both lead to the same conclusive value. And the same thing we can do below for women. It would be 0.35 was the calculation I was able to get for the P hat for women. So P hat 2 times 2629. And then 1 minus 0.35 times 2629. All greater than or equal to 10. And you'll notice because we know these values are going to be greater than or equal to 10, we don't actually have to calculate them. So with that out of the way, we know that we can show that both of these are approximately normal. So we've done great work. We set up our parameters for our situation. We've got our assumptions in check. Now we're going to name it. This is arguably the easiest part. This is called a two-sample Z interval. And then because I've set them up, P1 minus P2. The beauty of this, my legends, my friends, my heroes, is that we've already set up what P1 and P2 are with our parameter, so now we can just put it below. And you'll notice also sample Z interval is the same as it was for our one sample Z interval for proportions. The difference here is just that we're doing a two sample Z interval, this time for P1 minus P2. All right. Now we're going to actually give you the interval. Now this time, I'm just going to use 2 prop Z int. 2 prop Z int. Just like we normally would use 1 prop Z int, we will use 2 prop Z int. The inputs are x1, n1, x2, and n2, as well as confidence level. Now, for this particular problem, I'm going to go with confidence level first, just to get it out of the way. And it says we want a 99% confidence interval. So for C level, we'll put 0.99. Okay. Part of why I picked this problem is it makes it really easy on us to calculate number of men and number of women for x1 and x2. Remember that x1 and x2 represent the raw number of people that said yes to the particular thing we're talking about. So in this case, the raw number of men that said they live at home and the raw number of women. So that's 986 for men. 986 for men. And 923 for women. And then we have to put our totals in. So 2253 for men. Okay. Ooh. And 2629 for women. I'm gonna clean up those twos real quick. I made them real hideous. Okay, those are ugly too, but less ugly, more legible. Okay, and this is what you would input for this particular problem. Remember that if they give you just the p-hats, so p-hat 1 and p-hat 2, and the sample sizes, just multiply the two together to get the number of successes, the x1 and the x2, and just round, okay? And that will ensure that you have a whole number. And for that particular scenario, just round to the nearest number, right? So if it's like 581.0003, you're going to do 581. But if it's 581.923, you're probably going to do 582, for example. Excuse me. Now, when I run this in my calculator, you should be getting a confidence interval of about 0.051 up to 0.123. And that's our confidence interval. And now we're left with our final step, the conclusion. It's going to read the same as any other conclusion. We are 99% confident that the true difference in the proportions of men and women, 19 to 25, because that was the age range, who still, wow, a lot of writing, but we're heroic, we're philosophers, live at home, is between 0.051 and 0.123, and that is the Magic Legends. Okay, now that should feel very comfortable. Again, we followed the same process we've been following. Now, something I want to do before I clean this and finish it up, is I want to clarify with what this sort of sampling distribution between two values is. I want you to understand that unlike when we were doing confidence intervals before, these confidence intervals that we're doing now represent the difference between two values. So this is a distribution that represents taking the p-hat 1, subtracting p-hat 2 from it, and then running a distribution of all the possible versions of p-hat 1 minus p-hat 2. Some of which have, as we can see to the left, values where p-hat 2 is greater than p-hat 1. And some of them to the right, where p-hat 1 is greater than p-hat 2. And we just look at where that distribution sits, right? Right now, I'm assuming that this center is 0, right, where there is no difference. But in our particular confidence interval that we just calculated, we can see that all of our values are positive. So something to note about that is that if you were to ask, is it plausible that there's no difference between the number of men who live at home and the number of women, you would say it's not plausible. You would say, actually, my evidence suggests that it is quite likely that men live at home more often than women do, because we did proportion of men that live at home minus proportion of women who lived at home. And then we ran a confidence interval on that. So in this case, by doing that subtraction, any positive value is going to show more men living at home than women on average, versus any negative value would show more women living at home than men on average. I hope this is really clicking as to why this is so exciting. Before, a confidence interval used to just prove these are the plausible values for a single p-hat. But here, it's a comparative measure. This is showing that men are more bum chic and like to live at home and stay with the folks longer, perhaps, than women do on average. Now, I'm not trying to talk trash about men. I myself am a man. But it's a really cool thing that we can do these types of calculations and determinately in the real world say, wait a minute, on average, I have a confidence interval that, in this case, to 99% confidence. And by the way, those are real statistics from, was it the NIH? I believe it was. Yeah, NIH, National Institutes of Health, that show us that in reality, at least given the current data, it is plausible and it is quite likely to a degree of 99% confident that men live at home more than women do on average, like with their parents, so to speak, but in the age range of 19 to 25. Okay. Now, the last thing I really want to push home is I want you to remember, unrelated to panic, what confidence level is. And I'd rather not write it out. So what I'd like you to do is pull up the slideshow and go to the very end. The very last slide is a definition of confidence level, but this time it's a definition of confidence level for p hat 1 minus p hat 2, or p1 minus p2, I should say more directly, right? So if we were to take many, many samples, I'm going to say it out loud, right? If we were to take many, many samples, all of the same sample size, of the difference between proportion of men who live at home and proportion of women who live at home, and we were to make 99% confidence intervals of all of them, we would expect, on average, and I should say this, about 99% of those intervals, be very clear about that, of those intervals, to be between 0.051 and 0.023. Just kidding, that's wrong. Okay? What we would expect is for 99% of those intervals to contain the true population proportion. Remember that. Remember that our particular confidence interval is not special, okay? So one more time for the cheap seats. The end of your confidence level explanation. And again, the whole confidence level explanation is sitting in the slideshow, so do take a look at it. But the end part is 99% in this case of those intervals. This is the part people would get wrong the most. Contain what? The true, in this case, true difference. And then you would give context for p hat 1 minus p hat 2, or p1 minus p2. Okay, we've gone through and kind of established confidence level. Again, this is going to sound a little fuddy-duddy unless you go in and take a look at the slideshow, so do hop on the slideshow and look at the last slide where I define confidence level for you in depth. But we went and we did panic, and we did every step to understand the difference between these two values and solved it together. I'm so proud of you. Make sure to complete the homework and ask me any questions if anything doesn't make sense. I hope you're feeling magical. This is going to be one of the shorter video notes because we've already done so much with confidence intervals. So something I'd highly recommend is if you felt like anything here we kind of glossed over too quickly, make sure to go back to confidence intervals for proportions when it was one sample and watch that notes video too, because it will inform all the ideas here. This is just us doing it with two samples. I'm so proud of you. I'm so thankful to be your teacher. Thank you for everything you do. Miles adores you. I adore you. This is Mr. Mays signing off.